Okay, so now that we've talked about establishing the idea of finding a function and its inverse by switching x and y, that the domain and range are found by finding the inverse function and finding its domain and range, we can now go through some problems that seem a little bit difficult and establish a few things. First of all, let's say that we're interested in finding the inverse of a function, in this case h of x, and determining the domain and range of both a function and its inverse. Well, we already know how to find the domain of h, right? Remember, if we've got a radical expression, we find the domain by setting the argument greater than or equal to 0. So in this case, if we set x plus 7 greater than or equal to 0, we're going to get x is greater than or equal to negative 7. And so our domain is going to be the set of all x values such that everything from negative 7 to the right, off to positive infinity, will be in the domain. But what about the range? Well, recall we said that the range is going to be the domain of our reciprocal function. So let's find our inverse function. So let's try and find our inverse function right here. We set y equal to 3 plus the square root of x plus 7 to begin. And now we're going to switch x and y. So right now, I can tell you that when I swap x and y, x is equal to 3 plus the square root of y plus 7, I can tell you right now that the inverse function domain will be the range, and the inverse function's range will be the domain of the original function. Okay, so what do? Well, let's solve for x. So we're going to subtract 3 from both sides. We'll get x minus 3 is equal to the square root of y plus 7. Now to get y by itself, we have to undo that radical, which means that we have to square both sides of our equation. X minus 3 squared will equal y plus 7. And, I'm not even going to bother squaring this. I'm just going to isolate y by subtracting 7 from both sides and writing that y is equal to the quantity x minus 3 squared minus 7. So far we have our inverse function, h inverse of x, which is the quantity x minus 3 squared minus 7. Now stop and think about that one for a moment. When it comes to finding domain and range, we've got a little bit of a problem here, or so it seems, right? Because maybe you said to yourself, well, Professor Peoples, didn't we get done saying before that when we had something like a parabola, that was not one-to-one, and therefore it didn't have an inverse function? What do? Well, in this case, let's step back. When we swapped x and y in our second step, what happened? Well, in our first expression, we know that we get x is greater than or equal to negative 7. So, for our inverse function, when we switch x and y, we knew that y had to become greater than or equal to negative 7 in order to make all of our x and y values switch. Well, what could we said about the values of y right here? Well, what is the smallest y value that I can get out from this function? Y has to be greater than or equal to 3. Why, you might ask? In this case, if I look at my function and I were to graph y equals x minus 3 squared minus 7, what would happen? What would happen is that I would get a graph. I'm going to graph this function right here. Oops, come on. Let's see if I can do this over here in some sort of reasonable way. Let's type in this function right here. We've got y is equal to the quantity x minus 3 squared minus 7. Whoops, back up right there. Okay, we've got this function right here, y equals x minus 3 squared minus 7. If we were to plot this graph, kind of weird. Let me get a handle on this one so we can see this graph shifted properly. What could we say about it? Well, if we look at this graph right here, there we go, look at what happens at x equals 3. We get our vertical asymptote, right? Hold on, let me zoom in on this graph so I can get a better picture of what's going on for you. This is a function that has a vertex at negative 3, 7. It is not one-to-one, except for the fact that this part of the graph right over here is not in the graph, right? Because what would happen? Well, in order for that to happen, that would mean that this graph that has points on it, such as negative 7, 3, would have to have 3, negative 7. It would also have to have 2 points. But let's look at the graph of its reciprocal right here. We'll note that the graph of y equals 3 plus square root of x plus 7 right here in orange compares to the graph of y equals x minus 3 squared minus 7. We have to limit the graph of this second function right here, this function in purple, so that we only have one side. So what we would do is that we would purposely state that in our inverse function, h inverse of x equals x minus 3 squared minus 7 as long as x is greater than or equal to 3. And so what we're doing is we're limiting this function to being one-to-one by just choosing this portion of the function right here to plot. So let's see if I can get a decent looking plot right there. I know this isn't exactly great, but you get the idea right here. My graph of the inverse function. So we can just pull that off there. Come on now. There we go. Come on now. Doesn't want to play with it. Alright, anyways. So what would happen is that we would only take that one piece of the graph and we would say that this is our inverse function, this one-to-one piece. So there's our inverse right there. Alright, I'll give another example just a moment so we can see how this works out.